In this video, we look at something called combinations. So a combination is a way of choosing or grouping a set of R objects, so a small set of R objects, taken from a larger set of N objects. Basically what we're doing is we're looking at subsets of a larger set. It's very similar to permutations. The big difference here is that when we talk about combinations, the order does not matter. So if I think about having a set of 10 candies, and I'm going to choose 5 of those candies, and I'm not interested in the order, that's what we would consider a combination. So all of the different ways that I can pull 5 candies from those 10 would be a combination. So the number of combinations is given by the formula here, n choose R. So this is some new notation, and we read this as n choose R. So we have n objects, and we want to choose R of them. Choose R, and choose R. The other way we can write this, and you'll see it written in a bunch of different ways. Some books might write it as C bracket n comma R, very similar to the permutation notation. Or you may even see it written with a subscript, subscript n, capital C, and a subscript R. All three of these mean n choose R. And the way that we calculate a combination, a combination is basically the same as a permutation. So if you look carefully here, you'll see the permutation formula right here. So this is how we described permutations right here. N factorial over n minus R factorial. So basically a combination is just a permutation, but then we have to divide out all of the different orders that end up being the same, and that's what this R factorial is. So we're dividing out all of the ways that we get those repeated sets. Let's have a look at how to use the equation and calculate a combination. So again, the way that we read this right here, this is 12 choose 5. So 12 choose 5. We're just going to use the equation here. 12 choose 5 should equal, let me just switch my pen. So 12 choose 5 should equal 12 factorial divided by 12 minus 5 factorial times 5 factorial. Just extend that a little bit. When you do this on your calculator, make sure that you indicate somehow on your calculator. You use a set of brackets, you can press the equal sign, but you want to divide the 12, you want to divide the 12 factorial by all of this. If you just type 12 factorial divided by 12 minus 5 factorial times 5 factorial, the times 5 factorial is going to do this instead. So you need to make sure that you type that into your calculator appropriately. So either using the brackets on your calculator, like I've indicated in red here, or just pressing an equal sign. So 12 factorial divided by 12 minus 5 factorial equals, and then divide that again by 5 factorial. Lots of different possibilities there. I tend to use brackets, but that's just me. So we can simplify this a little bit. 12 factorial, 12 minus 5 is 7, so we get a 7 factorial in the denominator and a 5 factorial in the denominator as well. And if we sort of work that all out, plug that into the calculator, 12 factorial divided by 7 factorial times 5 factorial. Again, using brackets here or doing division twice, doesn't really matter, but we should get 792. And the nice thing about this is that you can check your answer. Your calculator, if you have a scientific calculator, in all likelihood, it probably does permutations. So you're probably looking for, it probably does combinations, since that's what we're doing here. You're probably looking for a button that looks either like this. It may look like this, or it may look like this. So somewhere on your calculator, you'll probably see that. And most calculators, the way that you do it is you type in your number. So in this case, our number was 12. You type in the number of objects that you have, your button, which might be this, it might be one of the others, and then the number that you want to choose. So if I type that into my calculator right now, I 12 choose 5, and I press equals, and I get 792. So that's a nice way that you can check to make sure that you did your calculations correctly. Let's move on to this next example here. Similar sort of idea. The notation looks different, but it still means the same thing. So in this case, we're looking for 7 choose 7. So 7 choose 7 is going to equal 7 factorial over 7. Oh, forgot the factorial. 7 minus 7 factorial divided by 7 factorial. We'll simplify this. We'll leave the 7 factorial for now. 7 minus 7 is 0. And the 7 factorial stays the same. Just a reminder that 0 factorial is equal to 1. That's by definition. So what we end up with then is 7 factorial divided by 1 times 7 factorial. 1 times 7 factorial is just 7 factorial. 7 factorial divided by itself, we get an answer of 1. If you think about it, without doing any calculations, you think about this for a minute, it kind of makes sense. We have 7 objects in a hat, say, 7 names in a hat even. We want to pull out 7 of those names. There's only one way for us to do that, and that's by pulling out all of the names. So even without doing a calculation here, logically thinking through what's going on, we should be able to come up with an answer. All right, let's move on here. Here's an application kind of question where you can use combinations. So remember, with combinations, the order is not important. So that's the difference between a combination and a permutation. So in this example, we have a gardener who bought some plants at a nursery. So 5 geranium bushes, 3 rose bushes, and 4 evergreens. The nursery had 14 different kinds of geraniums, 12 different kinds of roses, and 5 kinds of evergreens. How many different purchases could she have made? So we look at this and say we have 14 geraniums to start with. 14 geraniums, and she's going to buy 5 of them. Well, how many different ways could she choose 5 geraniums from 14? Well, that's just 14 choose 5. So those are the geraniums. Put a little G down here to remind us that's for the geraniums. Then we move on to the next one. The next one are the rose bushes. So the roses. 3 rose bushes that she's going to buy, and there were 12 to choose from. I'll even indicate that here. So there were 12 rose bushes to choose from. She chose 3 of them. And then we can move on to the evergreens. So the evergreens were here. There are 4 evergreens that she purchased. There were 5 to choose from. That's, again, probably one that with a little bit of thinking you could probably figure out without having to go to a calculator. So we had 5 evergreens to choose from. 4 evergreens that she bought. Oh, and I didn't label the roses. So here we go. Here are the roses. Now remember, she's buying roses and geraniums and evergreens. So she's buying all 3 of these things. She's buying this one right here, and this one here, and this one here. And the number of ways that she can do that, because she's buying all 3 of them, we need to multiply these together. Technically, we don't need the multiplication symbol in between here. It's understood with the choose notation as it is. You could write it in if you wanted to, but you certainly don't have to. I'll write it in just to remind us that we're multiplying these 3 things together. So then we do the calculation. I'm just going to go to the calculator, do 14 choose 5. 14 choose 5 is 2002. 12 choose 3 is 220. and 5 choose 4 is just 5. So we multiply that all out, and we get, what do we get here? We get 2,202,200. So that's how many different purchases she could have made from the plants that were at the store, based on the number of plants that she wanted. So that's a quick introduction to combinations, as well as an example of when you might use combinations.